Hi everybody, welcome to another video in Statistics, Chapter 10, Hypothesis Testing regarding a parameter. So this chapter, we do a little bit different than the previous one. Not just we do the calculation, but we have to make a decision based on the calculation that we have. So, but first, before write the solution, we have to determine the question. So, in this case, we spend the first section talking about the language of hypothesis testing. So hypothesis is a statement regarding a characteristic of one or more population. So it is about the population, therefore it is a parameter. In this chapter, we look for hypothesis regarding a single population parameter. Right, so only one population here. So here's some example. In 2008, 62% of American adults regularly volunteered their time for charity work. Right. A researcher believes that this percent is different than today. Right. So this say we said the proportion is 62%, and now the researcher believes that it's going to be different than that. According to a study published in March 2006, the mean length of the phone call is 3.25. So we said the mean is 3.25, and the researcher believes that the length has increased. So now, this is a statement. What they believe is going to be more than that. Using an old manufacturing process, the standard deviation is said to be 0.23 ounce, and then the quality control manager believes the standard deviation has decreased. Right. So original hypothesis is a statement like that, and now if we test, it said that believe the percentage is different than today. And now this one is believed that the length has increased. And this one believes the standard deviation has decreased. Right. So, hypothesis, as later on we'll see that two hypotheses, and will be written like this. Right. Just moving on. We'll get back to define the hypothesis later. Right. Hypothesis testing is the procedure based on the sample, evidence, and probability used to test statement regarding characteristic of one or more population. Right. It's not much. Just some terminology. We don't have to actually go to an example to explain it yet. Right. Steps to do the hypothesis testing is we make a statement regarding the nature of the population, something like this. Next, we collect the evidence to test the statement. So, and then we analyze the data to assess the plausibility of the statement. Right. Now, it's something more the line of what we did earlier here. The null hypothesis denote H naught is a statement to be tested. The null hypothesis is a statement of no change. So the null hypothesis H naught, a statement of no change, no effect, no difference, or true, and is assumed true until evidence indicates otherwise. Alternative hypothesis H1 is the statement that are trying to find evidence to support. Right. So the null hypothesis is no change, no effect, no difference, and that also we consider to be a status quo. And the alternative hypothesis denote H1 is a statement that we are trying to find. Right. And the example to this is a justice system or the court. which we assume that a person is innocent until proven guilty. So that is the assumption, right? So in that case, the status quo here is that person is innocent before going to the court. So the status quo will be innocent, and the alternative hypothesis is that the person is guilty. That is the burden of the prosecutor. The prosecutor try to find the evidence to support that the person is guilty. If the evidence is not enough, then the person remain innocent. The burden of proof is on the prosecutor to find that the person is guilty. Alright, we'll get back to that in a minute. Right, now mathematically or in statistics, when we write the hypothesis, will be like this. So we say the parameter equal to something. That for the null hypothesis. Remember, the null hypothesis is a statement of no change, equal, no difference, status quo. So that's why null hypothesis always equal to. And the alternating hypothesis is not equal to, could be not equal to, less than, or greater than. Depends on the problem we're working with. That is, the null hypothesis is a statement of the status quo, no difference, and always contain the equality, meaning equal sign in the null hypothesis. So for the null hypothesis, always an equal sign. The null hypothesis is assumed to be true until we have evidence to support the contrary, and we seek the evidence that support the statement in the alternating hypothesis. Right, here's some example. Right, as we mentioned earlier, that we'll get back to this. So we said that the proportion is 62%, and it is equal to, so that is the null hypothesis. The alternative hypothesis is something different than this, and it's said to be different today, so it's going to be different than 62%. Next, the mean length of phone call equal to, so we write that out first, and if it has equal, that is the null hypothesis. And the H1, this one has increased. The next one, standard deviation is 0.23. That is the null hypothesis. And the alternative hypothesis is something it's not equal to. And this case is decreased, so it's less than 0.23. Right, we will have more example in a little bit, but that's what we have for now. The null hypothesis where we have the equal sign, and alternative where we have not equal to, greater than, or less than. Right. Next, type 1 and type 2 error. There are 4 outcomes of hypothesis testing. We reject the null hypothesis when the alternative hypothesis is true. This decision would be correct. We do not reject the null hypothesis when the null hypothesis is true. This decision would be correct. And next, reject the null hypothesis when the null hypothesis is true, type 1 error. And do not reject the null hypothesis when the alternative hypothesis is true, is type 2 error. Alright, that's obviously confusing, but when we go to a few examples, that will clear up a little. But now, let's say it, reject the null hypothesis when the alternative hypothesis is true. So this is correct. Or if we do not reject the null hypothesis when the null hypothesis is true, this is correct. Next, if we reject the null hypothesis when the null hypothesis is true, this is type 1 error. And type 2 error is do not reject the null hypothesis when the alternative hypothesis is true. This is type 2 error. Right. So that's just some definition, but how that actually work in some application problem. Right. Here we have the first example. Write 4 outcomes for the following hypothesis testing. Here is the scenarios. You are a paramedic at an accident site with an unconscious person. The hypothesis is a person may or may not be dead. Decision: provide treatment for the person or not. Right. So let's say if we are a paramedic, we arrive at an accident scene and with an unconscious person. What would be the null hypothesis? Remember, the null hypothesis is statement of status quo, unchanged, no difference. So when you arrive there, we assume that the person is still alive, because that is the status quo, right? So assume that the person is alive, let's say it. And then the H1, of course, alternative, the person is dead. Right. Right, so that is null hypothesis, alternate hypothesis. And then the decision. Is you provide treatment. That is one. Or you do not provide treatment. Now, let's just write out all 4 scenarios. Case number 1. I'm going to write that corresponding to what we have here. Case number 1. Reject the null hypothesis when the alternative hypothesis is true. So, type 1 error, we reject this. When the null hypothesis is true. So the null hypothesis is true, the person is alive. So for number 1, the null hypothesis is true, but we reject it, meaning H1, H0 is true, but we reject it. So that is type 1 error here. So what actually happened? What actually happened is H0 is true, meaning the person is alive. We reject that. That means we do not follow that H0 is true. That means a person is alive, but we do not provide treatment. Right? That is the decision based on the fact that we reject that is true. So person is alive. But we do not provide treatment. So this, of course, is the type 1 error. Now let's go to the second scenario here, where we say the null hypothesis is true and we do not reject the null hypothesis. Notice the language, we never accept something, we always reject or do not reject. Just like in the court system, it's always guilty or not guilty. It is never, the verdict is never innocent. Right, next. This case is the null hypothesis is true. And we do not reject it, or we accept it, but we just say we do not reject instead of accept. Do not reject. I mean the person is alive. And we do not reject the fact that the person is alive. That means we'll provide the treatment. Right. So this, in this case, this is a correct decision. That is type 1 error. Right. Number 3. Let's say in this case, the alternative hypothesis is true. That means the person is dead. And we reject the null hypothesis. So H1 is true. And we reject H0. Right. So the person is, H1 is true, meaning the person is dead. This is the reality. And then we, a paramedic, we say that we reject the null hypothesis. That means we reject the fact that the person is alive. So we do not provide treatment. In that case, this is a correct decision. And case number 4, type 2 error, when the alternate hypothesis is true and we do not reject the null hypothesis. So H1 is true, and but we do not reject H1. Do not reject the null hypothesis, sorry. So H1 is true, meaning the person is dead. Person is dead. But we do not reject the fact that the person is alive. That means we accept that the person is still alive. So we still provide treatment. Still provide treatment. And that is the type 2 error. Right. So those are 4 scenarios. Of course, the correct decision would be good. Now focus on the type 1 and type 2 error. Type 1 error is that the person alive, but we do not provide treatment. This would be the worst compared to this. The person is dead and we try to provide treatment. So we try to save a dead person, which is just silly. But if we do not helping a person that is alive, that is a crime. So this is a lot worse than this case, right? So this is 4 different scenarios. Right, look at another example. You are a jury at a trial. The hypothesis, a person may be innocent or guilty, and the decision is that let that person go free or send that person to jail. Alright, so the null hypothesis, remember, it has to be a status quo. Before a trial, that person is innocent, so the status quo would be innocent. because of that, H1 will be opposite to that, of course, will be guilty. And the prosecutor will try to show that the person is guilty. The person at trial, that person doesn't have to prove anything. The burden of proof is on the prosecutor to show that the person is guilty. Right, so that's the first part. And then the decision is let the person go free or send that person to jail. Just go free or jail. Let's look at the 4 outcomes. Right, case number 1 is type 1 error, where the null hypothesis is true. That means the person is innocent. It is true, but we reject it. So in reality, that equivalently say that H0 is true, meaning the person is innocent. But we ignore it. We say the person is not. So we send that to jail. And so that means the person is wrongly convicted, because that is the type 1 error. Okay, so that means wrongly convicted. In the what we've been doing, that is type 1 error. Right. Case number 2, scenario number 2, the null hypothesis is true and we do not reject it, so H0 is true and we do not reject it. So H0 is true, meaning the person is indeed innocent. And the jury let it go free. In that case, that is good. The innocent person go free. That's the correct decision, right? So, innocent person goes free. This is, of course, is the correct decision. Right, case number 3 is also correct. The alternative hypothesis is true, meaning that it is guilty. And we reject. So H1 is true, meaning the person is guilty. And we reject that the person is innocent, or H0 is innocent. So we said that person have to go to jail. That decision based on we reject the notion that the person is innocent. So in this case, the person is guilty, that go to jail. So that is justly convicted. In that case, that is correct decision. Right, number 4, type 2 error. That is, alternative hypothesis is true and we do not reject H0. And do not reject. So the person is guilty. So that is the reality. But we do not reject the innocent notion. So that means we let that person go free. That is the decision. So in this case, we have the guilty person go free. And that is incorrect decision. Right. Now let's discuss, of course, when it's correct, then it's good. Now let's discuss the type of error. So, is wrongly convicted an innocent person, or we let the guilty person go free? Which one it was? Right. The justice system in America is saying that the first one is worse. So we assume that the person is innocent, and so that is the language before the verdict. Usually something like this. The judge will advise the jury something along this line. We said that unless you believe the person is guilty beyond a shadow of a doubt, or beyond the reasonable doubt, unless you believe that the person is guilty beyond the reasonable doubt. If you not say that, if you cannot say that, if there is some reasonable doubt, then the person is innocent. But of course, we're not saying that person is innocent. We just say the person is not guilty, right? So that is the language of this. The court system is just exactly like the language in statistics. Once again, the verdict is guilty or not guilty. So either we reject the null hypothesis or do not reject it, right? We never say the person is innocent, right? And then we talk about the reasonable doubt later, but that's what we have, right? I think that in our example, we can just skip this one. Right, definition. Let alpha, the probability of type 1 error, rejected H0 when H0 is true, and beta is type 2 error. The probability of making type 1 error, alpha, is chosen by the researcher before the sample data is collected. Alright, so we try to limit the alpha as small as possible. That means the probability of making a type 1 error, we try to keep that to the minimum, or we keep that at the acceptable level. Right. So as the probability of type 1 error increases, the probability of type 2 error decreases, and vice versa. Right. Here's the note that we have earlier. We never accept the null hypothesis because without having access to the entire population, we don't have exact values. That so another say in the core system is sometimes or most of the time we will never actually know the truth if it is guilty or not. So rather we say that we do not reject the null hypothesis, or we reject the null hypothesis. This is just like in the core system. We never declare a defendant innocent, but rather saying it's not guilty. So guilty or not guilty. Right. Right. So we get back to this. So the bottom line is it's nice to know that type 1 error and type 2 error, but just keep in mind that we try to limit the probability of making a type 1 error as small as possible, or at acceptable level. So we're going to set that level, and then we determine later. We'll do that in the next section. But for now, we just determine the null hypothesis, alternative hypothesis. That's good enough. I will not ask you about the type 1, type 2 error on the test. Right, here's some example. Write the null hypothesis and alternate hypothesis for that. Right, the mean annual return for an employee IRA is less than 5.2%. Right. Write the null and the alternative hypothesis for the test. Right, first we know it's less than 5.2%. And we said the mean population mean is that. Right, so we see that, and then we say, is that an H1 or H0? Well, when we write like that, it is less than, right? Less than. And it doesn't have the equal sign. So this must be H0. I mean, H1. And the null hypothesis is always equal to. So the H1 alternative hypothesis is going to be less than 5.2%. Right. Next, the owner of an outdoor store recommends against buying the new model of one brand GPS which have the standard deviation of 50 meters. So standard deviation of 50 meters. And then because the standard deviation that have more than the old model, so that could be worse than 50%, more than 50. So the old model will have 50 meters in standard deviation, which is terrible for GPS. And then equal to. So, of course, the one that has the equal sign is the null hypothesis. The one that doesn't is the alternate hypothesis. Right, next, the mean age of lawyers in New York is 46.6. Write the null hypothesis. Right, here we didn't say that is less than or greater than, so the alternative hypothesis is not that. So whatever has the equal sign is H0, whatever does not is H1. Right, next, the proportion of students at college who take more than 4 classes per semester is at least 60%. So we say P is at least 60%, meaning that will be 60% or more, right? At least is greater than or equal to. Right, then we have that, and we say, is that an H1 or at an H0? Before we do anything, the complement to this statement is less than, right? Now, when we look at this, we say whichever doesn't have the equal sign will be H1. Because the null hypothesis is always equal to. Right. So the wording a little bit different. Here we have at least. So it happens to have the equal sign here. Then we have to do the complement so it doesn't have the equal sign. And that will be H1. What's the null hypothesis is always equal to. Right, next. Restaurant claim that the average wait time is no more than 15 minutes. So no more than 15 minutes. The mean wait time, no more, meaning that it have to be 15 minutes or less. Of course, this have the equal sign like that. We have to write the complement where it does not have the equal sign. And then we say whichever doesn't have the equal sign will be h1. Right, so when we write the statement, if it has the equal sign, we have to write the complement, so it does not have the equal sign. And then we say the mean is greater than 15, and the h naught, the null hypothesis, is always equal to 15. Right. Like I said, I will not focus on the type 1 and type 2 error on the exercise, so we're going to skip this part. Right. Here's some more example. The mean age of principal of a local school district is 43.4 years. If the hypothesis test is performed, how should you interpret a decision that rejects the null hypothesis? Alright, so what is the null hypothesis? This is the mean is 53.4, right? So the mean is 53.4 years. H1 is not equal to 53.4. Right. Now we set reject the null hypothesis. That means we will go with the alternating hypothesis that this is not equal to. So when we reject, the language will be as follows. If we reject the null hypothesis, we say there is enough evidence to support that the mean is not equal to 53.4. Right. So just say there is enough evidence to conclude that the person is guilty. That's where we reject the notion of H0. Right. The mean monthly gasoline bill for one household is greater than 145. So the mean is greater than 145. So this one doesn't have the equal sign, therefore that will be H1, and H0 is always equal to. Let's see the decision. Here we reject the null hypothesis. It is there is enough evidence to support that the mean is greater than 145. Right. So if we reject H0, this language is there is enough evidence to support H1. The answer is always in terms of H1, the decision that is. Right, next, the dean of major university claimed that the mean number of hours students study is less than 6 hours. This one doesn't have the equal sign, so it has to be H1. Right? If it had the equal sign, we have to write the complement, and that complement will be H1. But the null hypothesis will always have the equal sign. Right? If it says that less than or equal to, then we have to write the complement which is greater than. In that case, that is H1. Alright. If the hypothesis has to perform, write the decision that failed to reject hypothesis, or we say do not reject. The language will be as follows. There is not enough evidence to support that the mean is less than 6. Right, it's always if it is not enough or not enough to support H1, the answer in terms of H1, it's just like the verdict is in terms of guilty or not guilty. Right, let's keep that in mind. With that, we finish this section. See you in another video in statistics. As always, thank you for watching.